Today, we will be pondering over a recent as well as an interesting topic, and that is the James Webb Space Telescope. It's the most powerful telescope ever launched into space, with a greatly improved infrared resolution and sensitivity, allowing it to view objects that are too old, distant, or faint to be seen by other telescopes. NASA launched the powerful time machines into space on December 25, 2021. NASA spent more than 30 years and $10 billion to bring the innovative James Webb Telescope to life. The question that comes up is the James Webb Space Telescope as incredible as the report claims? Is it truly capable of transporting us to another time period? To understand it in a better manner, let's dive into it further. The Webb is the result of a 25-year effort led by NASA, with significant contributions from European and Canadian space agencies, as well as a consortium of 14 European laboratories. The teams that built it included thousands of engineers, scientists, technicians, managers, planners, accountants, and secretaries. Gregory L. Robinson, who is a Webb program director at NASA headquarters, stated that this is the first time a NASA-led mission has ever attempted to complete a complex sequence to unfold an observatory in space, a remarkable feat for a team, NASA, and the world. It was formerly known as Next Generation Space Telescope, or NGST, but was renamed in September 2020 after James Webb. Some of the challenges faced were: 1. The weight of the telescope has a significant impact on the speed and orbit of the satellite. The scientists used a metal called beryllium, which later became the hero of the telescope due to its capability of being lighter as well as stronger, even in adverse climatic conditions. 2. Keeping Webb's mirrors cold. If you're in space, the side of your body that's in front of the sun would become very hot, while the other side may turn very cold due to the sun's rays. As a solution to this, it was decided to use sun shields, as the sun shield will allow it to cool down to a temperature below 50 Kelvin, or negative 360 degrees Fahrenheit, or negative 223 degrees Celsius. 3. Studying exoplanets. The most vital use of Webb's telescope is to search for elements of life outside of the universe. But the question that arises is, Webb is an infrared telescope, so won't it pose difficulty to study telescope because of the distance? The answer to this is the transit method, which involves looking for dimming of a star's light as its planet passes between us and the star. Webb actually works in conjunction with NASA's other solar system missions, such as ground-based, orbiting, and deep space observatories. Webb takes a deep look at Mars and the other giant planets, as well as minor planets such as Pluto and Eris, as well as small bodies in our solar system such as asteroids, comets, and Kuiper Belt objects. The Webb telescope was given 18 smaller mirrors that fit together like a puzzle. The mirrors are helped to reflect infrared light by a thin layer of gold. Webb's primary mirror is 6.5 meters in diameter, providing a wider field of view. Webb also has a 22 meter by 12 meter sun shield. The pressure to make sure every aspect of the telescope was flawless before attempting to launch it into space was immense, and it resulted in huge delays. However, since its launch in December 2021, every stage of implementation has gone off without a hitch. Looking at the James Webb Space Telescope, it's also different in its outward appearance when compared to other telescopes. The 6.5 meter primary mirror that'll collect and focus light from distant galaxies is made up of 18 hexagonal, gold-coated beryllium sections that'll reveal into location to fit the James Webb Space Telescope into a rocket. Along with its size, design, and distance from Earth, the James Webb Space Telescope would be able to detect faint objects with unprecedented resolution and sensitivity. Caroline Harper, who's the head of space science at the UK Space Agency, believes that Webb is going to rewrite bits of the astronomy textbooks. As it's generally seen, a team of astronomers have to look up if the satellite has some issue, but with the case of James Webb Space Telescope, as it's farther away in the universe, it's developed in a manner that there are very limited chances of default. Webb's main camera system, known as NIRCam, was used to conduct the alignment work. Engineers must now verify that this configuration works for the 3 remaining instrument packages on Webb. The telescope is designed to detect wavelengths exactly like these. It can also detect galaxies at greater distances than Hubble because it has more light-gathering power and resolution. It's also equipped for direct imaging of some extrasolar planets within our galaxy. The James Webb Telescope is more than a new scientific discovery. It's a symbol of cooperation and commitment. What more do you think are some of the discoveries that are yet to be unfolded by the great James Webb Space Telescope? Do let us know in the comments below. And that's all for today. Thanks for watching. If you enjoyed this video, then please like, share, and subscribe to our channel for more such exciting content. See you in the next video.